Hello everyone, welcome to another video from the AI Loop. Today we're going to be talking about neural networks. Well, we're going to start off by understanding the intuition behind neural networks, and I can assure you that there will be no math involved. Well, the idea behind today's video is to get a general intuition and to understand how neural networks work in general sense, so that it'll be very easy for you to go on and explore complex architectures and make sense out of them. So let's start the video. Well, let's try to understand how humans work and how we incorporate knowledge by first looking at this guy. Let's just say you're a human and I speak something to you, okay? And let's consider in the terms of an input. So I would expect an answer from you, right? Like, let's say this is the case that I'm giving you an input, that I'm speaking to you and I'm expecting you to talk back to me. Well, in this case, what is happening right here? When I talk something to you, you would think about it, right? Well, this process is where you use your knowledge, right? With the knowledge that you have, you would think about what I said and you would output appropriate words or sentences or whatever that is. So in the similar way, let's say you want to build someone like you. And why do we want to build someone like you? Is to automate tasks that do not need humans. Well, let's just say the person whom you want to build look like this, and you gotta give them an input and you're expecting an output from them. Now, the basic or the reasoning capabilities that give humans, humans get their reasoning capabilities from the knowledge they possess. Similarly, if you want something that you created to answer or this, you want it to possess some kind of knowledge, right? And here we will refer to the knowledge as weights. And weights are represented in the form of numerics or numbers. Okay, because I don't think humans ever came up with something else to represent the weights, but this works pretty well. So we're gonna stick with that. Well, now you have the input and you have the output and you have an agent. Let's consider neurons as agents for this case, and you have weight. Weight is the knowledge that the agent possesses. So whatever is the input that you give, the same way that you think, the agent multiplies the input with the weight and appropriately gives you the output. Now, for the tasks that we want to automate, these are not as simple to be handled by one neuron or one agent itself, right? Because imagine that every agent possesses weight in the form of a number, and let's say we have one agent that's right here, and that would be one number. And I think one number would be too generalized for you to get specific output. So ideally, you would have many agents. Well, the way that I'm saying that is, let me draw the most satisfying diagram of deep learning, I say. So we would have multiple agents, right? Let's consider multiple agents in this case. I don't know why that's filling up some of the circles, but yeah. And let's say we have multiple agents and each agent holds a weight. And that's the knowledge that the agent possesses. So now that you have an input task and you have multiple agents to handle a complex input task, we can expect this agent to work on something or to produce something meaningful. But let's consider this case. Let's say you're trying something new for the first time. Would you be good at it instantly? I don't think so. So in a similar way, when you do build a neural network or when you do build these colony of mini agents, they would ideally not be good at it like in the start. And let's try and run through an example and understand how these agents work, or how the input layers work and how the output layers work. Well, I hope you can see the diagram right there. Now, I don't really have an idea of the dataset that it belongs to, but let's just consider this to be a classification task. And well, this dataset, I think, is we're trying to predict the price range of a certain mobile phone. So let's just consider that. And this would be the target variable, and all of these would be our features. Now, how would you look at features? Or like, features are something that represent the input, right? Like as a whole, they represent the input, and output is what we want to map from the input. So we want to go all the way from X to Y, and we want our neural network to do that. So how many agents do you put in the first layer? How many neurons do you want to put in the first layer? Well, that depends every time on the input size. So what we're going to do is that we're going to count the number of inputs. That's going to be 1, 2, 3, 4, 5, 6, 7. So we have 7 inputs. So what we're going to do is put 7 agents, right? And these 7 agents would take 1 input each. So let's say we're starting with RAM. This would take RAM, and ideally everything would take the other ones until we get to the Wi-Fi. So how to work on this now? Well, now that we have 7 inputs, what we're going to do is we're going to connect it to some more agents, right? I'm not really going to draw a full connection here, but basically all of these are connected. Everything is connected to another neuron. So if you think of it, let's just calculate this as an output, and let's just consider this to be the neural network architecture that we have. And what we want to do is we want to map our inputs to the output, and the output, as you can see here, there are 2 categories. It's either 1 or 2. So we want it to predict if the mobile phone falls in the category of 1 or 2. So remember this, that every time the number of neurons in the first layer should be equal to the number of inputs that you're passing, so that each neuron can handle 1 input. So as you go further, what really happens is that you start condensing the input and try to get a representation out of it. So as we know, every neuron consists of weights. That's their knowledge. So every neuron here consists of a certain weight. And we know that the inputs, if we want to look at the table, are represented by numerics, right? Like let's say the Wi-Fi is 1 and the touchscreen is 0. That means there is no touchscreen. So this way, what really happens is that these inputs are being passed as numerics, and there are weights in here, and we're multiplying with them with the weights, and then we're adding them up. So let's say this neuron takes inputs from all the neurons here, so we're just going to multiply with all the weights and add them. And you're also going to pass it through an activation function, but we're not really focusing on that part right now. So let's just say you do that for everything, and then you end up all the way here. So every step you condense the inputs and you bring it to one single number here. So here, let's say the output that our neural network predicted is 2, right? Like let's say the neural network predicted it to be of type 2 or of price range 2. Now there is a way for us to tell. Now remember that when I did pick out the situation of someone being good at the work they do first time. So similar way, the neural network has predicted a wrong output, right? And now we want to correct it. Like we want to tell it how wrong it is. So basically this is where the loss function comes in, if you've ever heard of that term. So loss functions are basically a numeric representation to tell the neural network how far it is from the output. So basically, let's say this is 2, it predicted it as a class 2, but the actual class it belongs to is class 1. So you're just going to subtract these two. I mean, this is on a very simple level, but these will get complex as you explore the mathematics of it. But like, let's say we're getting the output as -1, right? Okay, so we're getting the output as -1. So like, it's off by -1 units. I mean, think of it intuitively. So the idea behind this part is that, so let's say as a human, if you do commit some mistake and I want to give you feedback, I cannot just tell you if you're right or wrong. The only time that you will benefit from my feedback is that if I give you a valuable feedback where you could like identify things that you could change to improve yourself. And similarly, the loss function gives it a numeric metric to say how wrong is the neural network's output, or how far the predicted result is from the actual result. And this way, with the loss function, we'll be able to calculate. And here a bunch of numerics are again involved. With the loss function, let's say this is the, let's consider this to be like a whole space of where you are, and this to be the actual output. Okay, we call this the local minimum, but let's just say this is where the actual output is. And with this loss function, let's say you fall somewhere here, right? And the idea is for you to get from this point to this point, right? And I don't expect you to understand this, but like just as a scenario, I just plotted in the graph. So let's say this is the output and this is where you are, and you want to go all the way from here to here. How would you do it? Now the loss function tells where we are in here, right? So with the loss function, we can know where we are, and we also know where the actual output is. With this way, we will get to know on which direction to travel. Like, let's say the output is 1 here, and the predicted output is 2, and the actual output is 1. So we can think of it as the neural network overshot the output. So maybe the weights are more. We don't have to have such high weights. We can reduce it to reduce the output so that we get the output that we desire. So similar way, if you could see here, this goes onto the positive axis, this goes onto the negative axis. So we are on the positive side, and we want to kind of step back to get to the actual output. And this way you would know which direction, or think of it as like the loss function tells you how far are you and how far you need to go, like which direction you need to go. Well, with this, we should go all the way from here to here. But there is another parameter involved here called the learning rate. Well, you're going from here, this point to this point, but how quickly do you want to go? Well, ideally, you would not be controlling it manually, right, as to where you want to step. So basically, what you would do is set up a number that tells you how far you should step down. In this case, where you're actually stepping down, I don't want to step all the way from here. Like, I don't want to miss this point, or I don't want to overstep. So I would consider a parameter called learning rate, and this learning rate would actually tell me the magnitude of the direction, that the magnitude at which I should step towards the intended direction. So these are the concepts that will help you understand which direction to go, and similarly the backpropagation happens. Well, thinking of it this way, after the backpropagation happens, the weights reset itself. So we know the weights are adjusting, and we give the neural network another try. We pass the input and see what the output is going to be. And we're going to do this repetitively until it starts predicting 1. And that's when we know we're getting the output we desire. Well, there are some things to understand here. Remember that although there's so much happening around, the only thing that's getting changed in the whole neural network is the weights, right? So this is what I meant when I said weights are the fundamental knowledge that give the reasoning capability for neural networks, just like knowledge gives the reasoning capability, or the consciousness gives the reasoning capability for humans. Weights are something that makes neural networks what they are. So apart from this, we can think of concepts like, let's say, the learning rate, or the optimizer, or the loss function, to identify which direction you have to go towards, and the backpropagation idea. All of these, we could think of them as the tools, or the set of tools used by the neural network to learn and reach its output. Well, this way, intuitively, I hope the concept of neural networks makes sense. Some of the concepts that I did illustrate here kind of deviate from the actual truth, but the idea is to give you an intuition And this is the way I learned to basically I kind of make up some assumptions and try to prove myself wrong or prove that the assumption is right until I get proven wrong, which happens in most of the cases. So that is the way that I like to learn. And once you explore and understand the concept of neural networks, you would enjoy it a lot more with complex architectures being built out of it, like the generative AI models, or let's say transformers, or anything like GANs. Well, I hope you gained a really good intuition of how the neural networks work. Well, this fundamentally helps us explore complex concepts even easily without concentrating on how the basics work. I hope to see you in the next video. Please subscribe to AI Loop if you find the content to be helpful.